Hi everyone, I'm Mr. Chia from AAA Teaching Center. So today we'll continue our lesson of motion. Recall that last lesson we learned about distance time graph and speed time graph, right? So can we get some information from the graph? Yes. We can get speed from distance time graph. And we can also get acceleration and distance travel from speed time graph. So let's see one by one. We can calculate speed from linear distance time graph. So we can calculate from the gradient. Let's say I want to know the speed of point journey PQ. So how can we know the speed, right? So we calculate the gradient of line PQ. So recall that for mathematics, the gradient is equals to y2 minus y1 over x2 minus x1. So this is the formula for gradient. So all this y1, y2, x2, x1, x2 is just coordinates. So let's see an example how to do it. Calculate the speed for each section of the graph, section A, section B, and section C. So we calculate the gradient of the line A, line B, line C respectively to know the speed. So for section A, we calculate the gradient of line A. So recall that the gradient formula is y2 minus y1 over x2 minus x1, right? Yeah, so for this case, for line A, y2 is 20, y1 is 0, x2 is 2, x1 is 0. So you get 10 meter per second. So let's see. Section B, you use the same formula, 20. So y2 is 20 for this case. Y1 is also 20. X2 is 6. X1 is 2. So you get 0. 0 meter per second. Okay, so what does speed equals to 0 meter per second means? Means that the object is not moving at rest. Okay, 0 ma, 0 speed. So for section C, you do the same thing. You calculate the gradient to obtain the speed. Speed is y2 is 40, y1 is 20, x2 is 7, x1 is 6. So you do the calculation, sorry, 6, right? So you do the calculation, you get 20 meter per second. So this is the answer. So what if the graph is non-linear? Let's say curve like that. How? Okay, we also calculate the gradient, but the instead of lines, right, it will give you a point, right? If you give a point and ask you to find the speed of that point at that point. So to calculate the speed at the point of time, the red dot here, how do you calculate the speed? You draw a tangent at that point. So what is tangent? Tangent is the line that touch the point exactly. So the blue line here, for example. So you calculate the gradient of this tangent to know the speed of the at the point of time, red dot here. So let's see an example. Calculate speed when time t is 5 seconds, the red dot here. So recall that the gradient is y2 minus y1 over x2 minus x1. So remember this formula. Okay, so speed at time t equals to 5 seconds, this red dot. So we draw the tangent blue line and we calculate the gradient of this blue line. So for speed equals to, okay, so for our case, this is y2, 40, 30 is y1, so x2 is 6, x1 is 4. So we do the calculation. Speed equals to gradient is y2, 40 minus y1 is 30. x2 is 6, x1 is 4. So you do the calculation, you will get 5 meter per second. Alright, so at time t equals to 5 seconds, the object is moving at 5 meter per second. Right, the conclusion is. Alright, so for distance time graph, that's all. We can only get speed from distance time graph. So for speed time graph, now a different case. For speed time graph, we can get acceleration. So from what? Acceleration, we can get it from the gradient of the graph. So let's see an example. Calculate acceleration for each section of the graph A, B, and C. So recall that the gradient is y2 minus y1 over x2 minus x1. This is the formula gradient. So for section A, you calculate the gradient of the line A. 6 minus 0, 2 minus 0. You will get 3 meter per second per second. Don't forget the unit. So for section B, you just do the same thing. You use the same formula, calculate the gradient, 6 minus 6, 6 minus 2. You will get 0. 0 meter per second per second. Okay, what does this mean? Acceleration is 0. So it means that the object is moving at constant speed. It's not accelerating. So it's moving at constant speed. Alright. So for section C, you calculate the gradient to get the speed. 0 minus 6, 10 minus 6. So we get negative 1.5. Negative 6 over 4. So negative 1.5 meter per second per second. So negative. Yeah, negative. So the answer is negative. So what does this negative means? It means that negative is deceleration. So the object is moving slower speed. The speed of the object is moving, getting slower and slower. Right. So for non-linear, what if the curve is non-linear? How do we get? We also get it from the gradient of the tangent. Alright, let's see an example. Calculate acceleration when time t is 25 seconds. Acceleration or gradient, formula gradient is y2 minus y1 over x2 minus x1. So for acceleration, right, gradient for this blue line, the tangent line, right? So for our case, y2 is this 40, y1, x2, x1 is 4. Okay, so for acceleration, okay, y2 40 minus 30, y2 is 6 minus 4. So what you get? You get 5. 5 meter per second per second. So when at time t equals to 25 seconds, the object is accelerating at 5 meter per second per second. So this is the conclusion. Okay, so we learn how to find acceleration from speed time graph, right? Now we learn how to find distance travel from speed time graph. This is the second information we can obtain from the speed time graph. Different from acceleration, we get it from gradient, right? For distance travel, we get it from area under the graph. Let's see an example. Calculate distance travel for each section of the graph A, B, and C. So you need to know the area of triangle and rectangle and square, all that. Alright, so for section A, we do it together. For section A, the distance travel is the area. So recall that what is the formula for triangle? So for triangle, right, is half times the base, means the bottom here, times the height, alright? The height, this is height, this is base. So distance travel is this triangle for A, for section A, so it's half times base. What is the base? 2 minus 0 is 2. So for the height is, for this case is 6. So you get the answer is 6 meter. For section B, the distance travel is the area under this is a rectangle. So rectangle is much simpler. It's just space times height. So for this case, base is 4, height is 6. Base times height is 4 times 6 is 24 meter. So for section C, a triangle again. So it's half time base time height. So for the base is 4, 10 minus 6, right? It's 4. Then the height is also 6. So you get 12 meter. Right? So this is the answer. So let's recap what we learned today. We learned that we can get information from distance time graph. For example, like speed. We can get it from the gradient. The steeper the line, the larger the speed. Remember this. So for speed time graph, we can get acceleration and distance travel. Well, if you want to find acceleration, we get it from the gradient. If you want to find distance travel, we get it from the area. This is today's lesson. So next lesson, we will learn what is mass and weight. So stay tuned for the next lesson. Remember, we have our first lesson on 9 December 2024. So if you are interested, feel free to check out our website and contact our admin for more information. Right? Thank you.